Welcome students. In this session, we are going to see the next question. Let us read the question. Critically evaluate the significance of calibration in industrial measurement system. Illustrate your evaluation by considering any one instrument and analyze how calibration influences the accuracy of measurements that contributes to improving precision and also reduces the static error. So here calibration definitely will influence or will improve the accuracy of a measurement system. It will improve the precision as well. It reduces the error. This is the main effect of the calibration. After doing the calibration to a particular instrument, these are the factors that definitely will change. But here in the question, they are asking us to illustrate your evaluation. So here the choice is given to us. We can take any one example, any one instrument, and we have to prove that how calibration will have an impact on the measurement process. So first thing is, evaluate the significance of calibration in industry. So let us see. Generally, any manufacturing industry or the manufacturer, they know the importance of calibration. In this picture, it shows that he's doing some correction by comparing the measurement from an instrument to a known standard and adjusting the instrument in order to minimize the differences. So here, what actually calibration means? So it is an act of comparison of a particular instrument. So we will take one instrument, we'll compare that instrument with any one of these one. If this is our instrument, we will compare with first primary standard. We'll compare the instrument if we have with the secondary standard instrument, or else if we have an instrument which is having a higher accuracy than the instrument whichever we are using, we'll compare this instrument with an instrument which is having a higher accuracy. So that once we'll do some adjustment against some reference instrument, and which will therefore will try to improve the accuracy of an instrument. A continuous comparison takes place between an instrument if based with the other instrument. If you are having a availability of a primary standard, then you can compare with the primary standard. If you are having an availability of the secondary standard or with the working standard or an instrument which is having higher accuracy, you can do the comparison and do the corrections. That is called the calibration. While you're doing calibration, when you're doing this comparison, at step by step, you have to check all the values. That's why all the measurement range, that's why it is a feedback. It's a loop. That's why it is given by using this picture I have given. And next, while doing this calibration process, definitely it will ensure the accuracy and it will improve the consistency. It will maintain some consistency. That means precision will be increased. There will be compliance with standards and regulations. So the compliance will be like such as the maintenance of a National Institute of Standards and Technology. So it will be like when you are comparing with the standard instruments, once you calibrate that one, it will be having the same readings just like the National Institute of NIST standards also. Therefore, when you are improving the accuracy means you are minimizing the error on the other side. If you are doing a regular calibration like this, you can reduce the drift and some at regular intervals, the variability also be reduced and thus improves the lifespan of an instrument. And next one is the quality assurance. Once you are doing some measurement, if the measurement is accurate, then there will be an improvement in the quality also. Next comes facilitating traceability. So it should be traceable with the standards. So that is very important. Once you got some readings and these readings are traceable with the primary standard readings, with that database, then the readings are very accurate. So while doing some calibration, you can detect and correct the drift problem, thus overall optimizing the instrument performance. So here, these are the benefits of doing the calibration. Now, coming to the point, they asked us to take any one example. So calibration, you can calibrate a voltmeter, You can calibrate an ammeter. You can calibrate wattmeter. So what you can ensure by doing this calibration? So here, if we let us consider one voltmeter. After doing the calibration process, at regular intervals, it reduces the drift inside the voltmeter. What do you mean by zero drift generally? Yes, a small value will be indicated even when no input is applied, then that is called the drift. This type of problems can be reduced by doing the calibration. Sometimes there will be bias or offset or linearity issues will comes into picture. Due to this, while doing the measurement, the readings are deviated from the true value. Therefore, there will be a static error occurs while doing the measurement process. So, while doing the calibration of a voltmeter, after doing the calibration, the static error will be reduced and the bias will be adjusted and the instrument will perform linearly. And next thing is it also improves the precision of an instrument. How the precision will be improved? By reducing the drift. And by reducing the drift, we can improve the precision of the instruments. So thank you, students. This is all about the calibration.